Looking at rectangles, rhombuses, and squares and their properties. All of those are types of parallelograms. So everything that's true about a parallelogram is also true about rectangles, rhombuses, and squares. The opposite sides are still congruent. The opposite sides are still parallel. The diagonals still bisect one another. They cut each other in half. All of those things that were true about a parallelogram, still true about the special parallelograms. But there are a couple of new things for each of them. One will be about either the angles or the sides, and the other will be something about the diagonals. So a rectangle, you all know this, is a parallelogram with 4 right angles. This is a rectangle. Again, a rectangle has all the properties of a parallelogram. The additional part, so you need to know both things. Almost everybody knows that the angles in a rectangle are right angles already. The thing you may not know is that unlike ordinary parallelograms, the diagonals of a rectangle are congruent. That's something new that you may not know. The diagonals of a rectangle are congruent. So in this diagram, if ABCD is a rectangle, then the distance from A to C is the same as the distance from B to D. And that's because it doesn't lean over. If you've got an ordinary parallelogram like this, where it leans over, I'm going to draw the 2 diagonals. This black diagonal is short, and this red diagonal is long because of the direction that it leans. But because a rectangle doesn't lean one way or the other, the 2 diagonals are the same length. So let's find the measure of each angle and segment in rectangle JAME. All right. Let's start with the angles. Remember, we know that this is a parallelogram because a rectangle is a special parallelogram. So things like alternate interior angles are still going to be congruent. So since this angle is 52, so is this one. And we know that at a rectangle, we have a right angle at each vertex. So each of these whole angles is 90. So if this angle is 52, we take 90 minus 52, and we get that this angle is 38 degrees. So then by alternate interior angles, this angle is also 38 degrees. And a lot of people get stuck right there. Okay, they're like, I don't know how to find those other angles. I don't know how to find the angles in the middle, and I don't know how to find these 2 angles at J and these 2 angles at M. Here's the key to this. What's true about the diagonals in a rectangle? It's written right above this. What's true about the diagonals? They're congruent. And because it's a parallelogram, they cut each other in half. That means all their halves are congruent, which means all 4 of these segments are congruent. So then what kind of a triangle is this triangle down here at the bottom, triangle ESM? Yes, it's obtuse. Classify it by its sides. It's isosceles. You got to say it louder or I can't hear you. So if it's isosceles, remember this is the base at the bottom, so these 2 base angles are congruent. So if this angle is 38, so is this one. And then, well, triangle SAM is an isosceles triangle, where AM is the base. So this angle's 52. And either you can keep doing that or you can do alternate interior angles to find the lower angle at J is 52 over here and the upper one is 38. The only angles that are left to find are the ones here in the middle. You can use angles of triangles, which takes a little longer, or if you want to be quick about it, you can use exterior angles of a triangle. Either one of them is fine. If you want to use the exterior angles, remember that an exterior angle like this one to this triangle over here, see how that angle is outside of triangle SAM? All we've got to do is add the 52 and the 52 together. That's 104, that's angles 104. So this is 104. And likewise, adding the 38 and the 38 together, that's 76. These two angles are both 76. So that's all the angles. Now let's switch and find sides. All right, so if this side is 30, well, I know this side is 30. And since SM is 17, I know that JS is 17, ES is 17, and AS is 17. I know all those are 17. Which leads us with finding the length of AM, the length of JE. Like I know everything else. You have to not look at the little triangles to do this. You got to look at one of the big triangles, like triangle EAM. I think sometimes it's easier if you'll draw it separately so that you can see that triangle. The angle at M is a right angle. The length of EM, down here on the bottom, is 30. And the length of EA, this diagonal, is 17 plus 17, which is 34. Well, now I got to find the length of AM. How can I find the length of AM in this triangle? What theorem do I use? Yeah, I'm going to use the Pythagorean theorem. It's a right triangle, and I know 2 out of the 3 sides. So I'll have 30 squared plus AM squared is equal to 34 squared. 30 squared, I know that one. That's 900. That's not hard. 34 squared, I don't know that one off the top of my head. So we'll multiply it out. $11.56. Subtract, and I get that AM squared is 256. So AM is the square root of 256. That's one that you should have memorized. That is a perfect square. Who is it that knows those usually? Oh, it's Isaac who usually knows those. Do you remember that one? Yeah, square root of 256. Do you know that one? If you don't, it's okay. It is 16. Nicely done. Maybe soon some of the rest of you will start knowing those. All right, let's go on to the next page. Now, a rhombus is a parallelogram with all sides congruent. So it's like a square that's been tipped over part way. Since it's been tipped over part way, the diagonals are not going to be congruent. WY would be a lot longer than ZX would be because of how it's leaning that direction, right? But there are things that are true about the diagonals of a rhombus. And that is that they are perpendicular to each other and they bisect the angles. So that means that these angles are all going to be right angles. And it means these two angles are congruent to these two angles. And that these two angles are congruent to these two angles. Okay. So let me tell you what I think makes rhombuses easier. Most of the time they're drawn like this. If you'll take your paper and turn it so that it looks like this, I think it's a lot easier to see that those are right angles. It can be hard to see that these are right angles when this is at an angle like that. But if you turn it like this, it's really easy to see that those are right angles. And it's also really easy to kind of look at it and go, yeah, these two angles look like they're the same size. Okay? And these two angles look like they're the same size. Just it's an easier way to look at it, but they're almost always drawn this way. So let's find the measure of each angle and segment in rhombus KYRA. All right, so let's start with the angles. Again, you may want to turn your picture so that it looks like what you called maybe in elementary school. Did you ever call it a diamond instead of a rhombus? Many of you did. Okay. If you draw it to where, if you turn it to where it looks like a diamond, it's easy to see where the right angles are. The right angles are in the middle. Pretty much everything that was true about a rectangle is reversed for a rhombus. In a rectangle, the right angles are on the corners. In a rhombus, the right angles are in the middle. If this angle is 28, by alternate interior angles, so is this one. And the angles cut each other, the diagonals cut the angles in half, so each of these is 28. Now we've got 2 out of the 3 angles in the right triangle. Since it's a right triangle, all we have to do to find the angles that are is take 28 from 90, because the 2 acute angles add up to 90 in a right triangle. These angles are both 62 degrees. So now we have all the angles. For the segments, it's a rhombus, so we know all the sides are the same length. So if one side is 12, all the sides are 12. Chris? And if KD is 8, then DR is 8. The diagonals in any parallelogram cut each other in half. Now, we need to figure out how long DY is and how long AD is. We also need to know how long AY is But AY is not part of a right triangle, but DY is. If you have it with Y at the top, that looks like this, where that's a right angle. This side is 8, and this is 12. How can we find the length of YD? Yeah, we're going to use the Pythagorean theorem again. We'll have 8 squared plus YD squared is equal to 12 squared. So that's 64 plus YD squared is 144. Subtract and we have YD squared is 80. So YD is the square root of 80. I need to simplify that. We haven't simplified a square root in a while. You can start by dividing it by 2, and it's really easy to divide by 2. It turns out if you divide by 5 first, the answer pops out a lot quicker. If we divide 5 into 80, that goes 16 times. And 16 is a perfect square, so I don't have to keep doing divide by 2, divide by 2, divide by 2. I can divide by 4 twice. That's the one time where you're allowed to use something that's not a prime number, if these two are going to be the same. So the square root of 4 times the square root of 4 is 4. And I still have a square root of 5 left. So each of these is 4 square roots of 5. Any questions about this example? All right, last one is a square. A square is a parallelogram with 4 right angles and all congruent sides. What do we call a polygon where all the sides are the same and all the angles are the same? Anybody remember that? Yes. It is, because all the sides are equal, but if all the sides are equal and all the angles are equal, if it's both, what is it? This word, at least, will show up on your quiz on Friday. It's regular. This is a regular polygon. All the sides are congruent and all the angles are congruent. So, because all the angles are right angles, it's a rectangle. Because all the sides are congruent, it's a rhombus. A square is a parallelogram and a rectangle and a rhombus. It's all of those at once. So it has all of those properties. So let's find the measure of each angle and each segment in this square. Well, because it's a square, all the angles are right angles. And because a square is a rhombus, all the angles in the middle are right angles also. If you turn it up on its side, you can see that those are all right angles. And also because it's a rhombus, these angles are going to be congruent to each other. So the angles in a square, it's really easy. It's either a right angle or it's a 45-degree angle, every single one of them. Then for the segments, well, if this side is 18, all the sides are 18. And then I've got a 45, 45, 90 triangle. Like if I look at the one on the bottom, it's a 45, 45, 90 triangle. So in a 45, 45, 90 triangle, do you remember how we labeled the legs and the hypotenuse? This is S, that's S, and this is S squared of 2. Very good. So S squared of 2 is 18. So we'll divide both sides by the square root of 2. We don't want to leave the square root in the denominator, so we'll rationalize by multiplying by the square root of 2 over the square root of 2. That's 18 square roots of 2 over 2 is 9 square roots of 2. So these are 9 square roots of 2. So all these half diagonals are 9 square roots of 2. All right, any questions about that? Okay, your assignment is in the book. Please go ahead and get started on that while I check your homework. And we'll go over the homework in just a couple of minutes.